So a little aerodynamics lesson. So this is the airplane I'm going to be talking about, the Questair Venture. Questair Venture has a cruise speed at 75% power of 240 knots. So that's about 4 nautical miles per minute. It has a stall speed of right around 61 knots. So if you take the ratio of its maximum cruise speed, and actually maximum will be 250 knots, but at 240 knots, and you divide it by the 60 knots stall speed, that speed range, you get a speed ratio of about 4 to 1. And that's a pretty outstanding speed ratio. And I'm going to show you a little bit more about that. And that's one measure of aerodynamic efficiency, particularly when you're talking about piston aircraft engines. Now, if it's a jet aircraft, you can put a giant jet engine on it. You can obviously increase that speed ratio, but for piston-powered aircraft, subsonic aircraft, it's a pretty interesting thing. And it doesn't necessarily just apply to high-speed, high-performance aircraft. You know, I have this Pegasus Air, which is a low and slow airplane for like backcountry flying, and it also has a speed ratio of a little over 4 to 1, because it'll cruise at 125 knots, and it stalls at 30 knots. And so what it says is that there could be different categories of aircraft where they excel in this particular type of efficiency. So, and I should tell you that, give you some examples. A Cub, like a J3 Cub, has a speed ratio of 2. Some ultralights have speed ratios of about 1.5. So they're not flying a whole lot faster than their stall speed. A Mooney, which is what we think of as a pretty efficient aircraft, has a speed ratio of about 2.9. A Bonanza has a speed ratio right around 3. And so that kind of tells you kind of the range of speed ratios. So let me play this first. Movie here. So this is from Aircraft Adventures. This guy he does special, he's really good. He looks at kind of these weird airplanes, these unique aircraft, and he does pretty good articles. So he contacted a number of us venture to find out more about this airplane. Pretty nice thing, but it's not a bad introduction, so let me play that.
Today, we explored an aircraft unlike anything you've seen before, resembling a tiny egg with wings. The Questair Venture's shape is both thought-provoking and yet puzzling. Why was it designed this way? Why is it so short? Can people actually fit in it? What's up with the landing gear? How do you even land this thing? Wait a minute, this tail looks familiar. Where else have I seen it? All these questions and more are easily revealed once you get to know the true story behind this fascinating design. The Venture.
So it's a pretty cool airplane. I think I've got another one I'll show you real quick. This just shows the Venture making a little pass. And it has a cool sound to it because it's got that 6-cylinder and stuff, 6-cylinder engine. And it really looks like it's going fast because it's short. You know, a small, little short airplane looks fast. Okay, so now you know what speed ratio is about. I'm going to talk a little bit about amateur-built aircraft in general, and this is titled Only in America. What a fantastic country. This is one of the few places I know that you can go and design your own airplane, build it, test fly it yourself, see if it's going to kill you, and you don't have to have any instruction to do that, and you don't have to have a pilot's license to do that. And that's the Part 103 ultralight class of aircraft. Now, isn't that incredible? The FAA will let you go out and kill yourself, and as long as it's just you, they don't care. It's a single-place airplane. So one step up from that is amateur-built aircraft, where you can do the same thing, but to fly it, you do need to have a pilot's license, which means you know, either light sport aircraft license or a private pilot's license to fly them. But what's really cool about it is, in addition, is that once the FAA is giving you an airworthiness certificate, which involves them coming out and inspecting the aircraft, and once you fly a test program for 40 hours of testing in a particular area that you define with the FAA, that's a safe area to fly, then you can enter what they call Phase 2. And Phase 2 lets you take that airplane that you designed, built, constructed, and fly it anywhere that any GA aircraft can fly in the national airspace system. So you can fly it over cities, you could fly at IFR, you could fly into big airports, small airports, just about any place. And which is really great. And the other thing they'll do for you is they will issue a special repairman license for that aircraft that allows you to not only work on it, modify it, but also to do the required annual inspection of the aircraft. So you don't have to hire an airframe and power plant mechanic to do that. So there's, you can save a lot of money. And you can build the aircraft oftentimes for half or even a third of what it would cost you to buy a new airplane with similar performance. So, only in America. Really great. Okay, there's a huge amount of diversity in experimental aircraft. Here's just some of examples, powered parachute, ultralight, a rocket-powered aircraft, jet-powered helicopters, biplanes, turboprops, crazy wild designs. I mean, there's just, this country is prolific with different types of aircraft designs that fall into this category. Okay, so what I'm going to do is compare the Venture and some other amateur-built high-performance aircraft to sort of the peak of piston aircraft design. And so aircraft design pretty much peaked towards the end of World War II with fighter aircraft. They had the newest aeronautical information for design, aerodynamics for design. They had big, powerful engines. They were single-place aircraft, so they flew fast. And so here's a few examples of them. The P-51 Mustang, the ME-109, the Spitfire, and the Zero. Looking at these aircraft, they had a top speed range of 335 to 435 miles an hour, 25,000 feet. Climb rates of 2,700 to 3,300 feet per minute. And their speed ratio, remember we were talking about that, ranged from 3.3 to 4.4. So let's compare these to some of the modern amateur-built aircraft that have been built. So this is a Venture. This is called a Thunder Mustang. It's a 3/4 scale of the P-51 Mustang. This is a turboprop called a Legend. Lancer 4P, that's a pressurized four-place aircraft. Cruises about 220 knots at 25,000 feet. Here's another four-place. It's a pusher with a Canard-type aircraft called a Velocity. It's also a four-place aircraft, and it'll cruise very nicely at about 200 knots at 10,000 feet. This is a Viper. It's pure jet, and here's one of the RV series, the RV-8, which is one of their more efficient aircraft. These aircraft have top speeds from 200 to 450 miles an hour, climb rates from 1,500 feet per minute to 6,000 feet per minute, speed ratios of 3.2 to 4.2. So you can see their speed ratios are right in there with those World War II aircraft. And I got to tell you, that's what it feels like when you're flying them. They are thrilling to fly, these amateur builds. So this just kind of interlaces those two. So this is top to bottom based on top speed. And the ones in red are the amateur-built aircraft. The ones in black are the military fighters. And so you can see they pretty much all line up and right up there along with the fighters.
Will, when you're talking top speed, is that top of green, top of yellow, VNE? when you do the speed ratio?
Yeah, so that's their
VNE?
maximum cruise, no, not VNE, maximum sustained cruise speed.
Okay, so top of the green arc, okay.
It's as fast as they'll go, basically, at either rated altitude 25,000 feet, or in the case of most of the amateur builds, it's between 8 and 10,000 feet. So, but it's not VNEs. VNE on these were considerably higher than that. So on a dive, you could go much faster than that. And that's true of the experimentals too. For example, on the Venture, the maximum sea level speed is 250 knots, but my VNE is 300 knots. And that's indicated airspeed. So let me talk a little bit about the Venture design. So the concept for this aircraft was to build a high-speed, high-altitude, efficient cross-country aircraft. And the Venture really excels for high-performance aircraft in terms of efficiency, and I'll talk more about that. And basically, they wanted to build an aircraft that could fly halfway across the country in 4 hours. And the way they did this was, first was low drag. How do we make this a low drag aircraft? The wing has an aspect ratio, that is the span of the wing to the chord of the wing, of about 10.4 to 1. That's, if you can consider more general aviation aircraft, those are more like 6 to 8 kind of aspect ratios. And that makes for high flyers. The higher the aspect ratio, the more efficiency the aircraft maintains as it goes up in altitude. The other one was to minimize the fuselage drag, and that's one of the reasons the Venture has such a short fuselage. It turns out if you look at aerodynamic shapes for fuselages, the optimum ratio of diameter to length for a fuselage is 4 to 1, kind of like that flat plate number. And so the Venture, that's what it is. The fuselage is a little over 48 inches in diameter, and it's about 16.5 feet long. So it's right in there. So that's the minimum design, a design for minimum parasitic drag. The Venture has got compound curves in it, so that everything in that airplane is curved. It's made out of aluminum, but everything has got an aerodynamic curve to it. And so if you look at the wing, not only does it curve from leading edge to tailing edge in an airfoil shape, it also curves span-wise from inboard to outboard. So everything's a compound curve. The fuselage is all compound curves, tail feathers, everything. And the way they did that was there was a new aluminum that came out called 6013. It could be stretch formed, annealed and stretch formed. So the way they would form these compound curves is they would machine out a very accurate mold for wings, for the fuselage, and then they'd grab this aluminum in the annealed condition with these huge grabbers, hydraulic grabbers, and they would just push it down over the mold. Just like you'd take saran wrap, right? Put it over last night's dinner or something like that. And then you'd cut the shape out afterwards. And then they would go back and heat treat it, and this aluminum would heat treat to a 12% higher yield strength than 2024 T3, which is the commonly accepted aluminum. And in addition to that, it was very corrosion resistant. And it turns out that this monocoque fuselage, which is the design, is the monocoque type design, so most of the stresses are carried in the skin. When you curve it like this, it's sort of like an egg, right? You know how tough eggs are because they've got all those curves? And the same thing with this fuselage. And I'll show you that makes it very crash resistant. Not crash resistant, but survivable in a crash. Now really, that's
He said,
there is crash resistant, and it is crash resistant, I'll tell you about that. But also, you want survivability. Because these airplanes typically have high landing speeds. The Venture has one of the lower stall speeds, but for high performance aircraft. But they generally have high landing speeds. And so if you're forced to do a forced landing somewhere and it doesn't happen to be a runway or a road, you can be touching down at 75 knots, and that's pretty fast. So another thing measuring aerodynamic efficiency is flat plate drag. And so here's what flat plate drag is. So what flat plate drag is another form of aerodynamic efficiency that engineers use to compare aircraft. And the way it works is, what would it look like, what would the aircraft's drag look like that would be equivalent to shoving a flat plate of a certain amount of area through the air at the same speed and the same density. And so by just looking at different flat plate drag areas, you can get an idea of, you're doing a great job of smothering that yawn. I really appreciate that. But now it's time for you to push that button. You can get an idea of how aerodynamic these aircraft are. So this is the flat plate drag area of a P-51. Now notice it's smaller than a 182. If you've ever stood next to a P-51, it's a big airplane. I mean, it is a big airplane, right? You got to climb up to get up into the cabin. And yet it has a smaller flat plate drag than a 182. So a P-51 at gross is 9,000 pounds, a 182 at gross is, where's Keith? What is it?
2950.
2950. So three times the gross weight. The reason they did this they got this with the P-51 was they went to laminar flow wings, laminar flow airfoil and wings, and they paid a lot of attention to making it just as sleek as they could. And so I'll keep going. Here's my Bonanza. You can see the P-51 just barely more efficient than the Bonanza, which is a four-place airplane, than the P-51. If you go over here, here's a Mooney, M201, known as a very efficient aircraft, right? We talked about that. This is the flat plate drag area of the Mooney, right here. And the Mooney, by the way, had that speed ratio of 3 to 1, which is pretty good for general aviation. And then here's the Venture. It's about 1.5 square feet. And this is one of the lowest flat plate drag areas of any of the amateur-built aircraft. So I wish I was going to bring it out today, but the weather is crummy. But if you stand at the Venture and you look at the front, you've got this fuselage, that's like this rounded square that's like 4 foot by 4 feet, 16 square feet. And then you got the wings, you got the tail surfaces. The air thinks it looks like that. Pretty phenomenal. Coefficient of drag is less than 0.02 for the aircraft. Okay, the other thing you need to do is get an efficient aircraft. Because you want to fly halfway across the country, what is it? That's 1,000 miles or more. You want an efficient engine. And about the time that the Venture was being designed, a little more on this later, Continental was coming out with a new engine with a specific fuel consumption of 0.38 pounds per horsepower per hour at its rated power. Now what does that mean? That means for every horsepower you generate, every 1 horsepower you generate per hour, it will burn 0.38 pounds of fuel. So to give you a comparison, most of the general aviation aircraft we fly are between 0.45 and 5 and 0.5. So a half a pound per horsepower. So this is like a 20-30% improvement in economy. They wanted the aircraft to be strong, capable of aerobatics, compound curve structure, and I talked about that. Okay, here's some stats on it. So the Venture, the air loves the Venture, and the Venture loves the air. It's a beautiful thing in the air to fly, and its performance is phenomenal. 250 knots, which is about 280 miles an hour, on 280 horse. 240 knots, that's maximum speed. This is the rich at peak. This is when you have a richer mixture in the aircraft, so this would be around 0.38 to 0.4 pounds per horsepower hour. About 16 gallons an hour. This is where I normally cruise, 225 knots, about 250 miles an hour, 50 degrees lean at peak, and so I'm actually running a little bit less than 0.38 pounds per, so burning about 11.5 gallons an hour. It also flies slow, it has a big speed ratio. Stall speed 68 knots, flaps up 63 knots. Mine is 63 knots flaps down. The published is 61. It has phenomenal stall characteristics for a high-performance aircraft. Essentially not much of a brake at all, and it's fully controlled. Aileron, the flaperons allowed to be fully controlled in a stall, so you can roll the airplane plus or minus 30 degrees in the stall. Good feedback on the controls. They're all harmonized, so they feel right to you, and I'll explain that later a little more. Service ceiling on a normally aspirated Venture is 30,000 feet. So it set one of the early time to climb records and also altitude record for, and it was a little over 33,000 feet. And it's designed for Part 23. For those of you who don't know, that's standard certification requirements for general aviation aircraft. Plus 5 Gs, minus 3 Gs with a 2,000-pound gross. Now, if you don't believe me, I could show you a bunch of these. But this is one from Steve Cook. He did a lot of, he flies a lot of Haitian relief effort flights, and he lives up in Kentucky, and he goes down to Florida to pick up an airplane to fly over to, on those flights. So he's flying his Venture down there. He's flying at 18,000 feet, so he's on oxygen. Venture isn't pressurized. His indicated airspeed is 175 knots. His true airspeed, that's how fast he's really going through the air, is 236 knots, which is pretty close to that 240, but he's at 18,000 feet instead of 10,000. He's burning 10.4 gallons an hour. And the wind at that altitude, according to the Garmin, is only his ground speed is only 237 knots. So basically there's only 1 knot of wind pushing him along up there. So these guys love to send these kind of pictures out to everybody and say, hey man, look at me.
Well,
Yes, sir.
so you say it doesn't, you said it was pretty smooth and brake on stall,
Yes.
and what's the flying characteristics like if you're in slow flight or?
So they're actually pretty good. So the nose is up a little more, right? Normally in cruise it's way down, it seems like. It's up a little bit more. And, but like over the numbers, I'm doing about 90 knots. And, you know, it's still got lots of roll. It's got full span flaperons. So the flaps are full span and they're coupled with the aileron. So it has really good roll authority.
Does that make it difficult to find the stall?
Well, not particularly, because mine doesn't have a stall horn, but it has an aerodynamic rumble, and it was designed into it, so that as you slow down, as you start to approach the stall, flow starts separating from the wing. Not all of it, you know, just begins to, and that's designed to hit the tail surfaces and cause the airplane to do this. So you know, as you'll be flying along, and you'll be going along like this, then it'll start, must have too much coffee, it'll start slowing down, and then it'll start doing this. And it warns you.
You probably have angle of attack, right?
No, I don't even have angle of attack in it. No, I don't have anything in it. It's pretty basic.
It sounds a little scary.
I do, so, I do have a stall horn for it. And I do have a stall switch to put in it, and I haven't put it in yet. But I think that would be a very good thing to, or to have angle of attack in it. I'm actually putting a Garmin panel in it, which has angle of attack, but I haven't done it yet.
As long as you have the right pitot.
Huh?
As long as you have the right pitot.
Pitot for
Yeah,
it?
because it'll have the angle of attack, part of the pitot.
Yeah, so, I might have to put one of those in where they put the ports above and below the wing and they sample it, because it comes with a special pitot tube on it. It's got a really long pitot tube, and that's because the Venture is doing about Mach 0.32 when you're in cruise. So you are getting some compressibility effects. In fact, the leading edge of the Venture heats up, I think I calculated about 13 degrees in cruise due to compressibility. And so they have the pitots, you want to stick it out away from that, so it's got a long pitot tube on it.
Well, on the Garmin, you can set it up for Mach numbers too.
Oh, can you?
Yeah.
Oh, okay, cool, wow. A lot of these guys, these airline pilots, they'll talk Mach numbers instead of knots when they're talking about Ventures. Okay, I want to tell you a little bit about the history of the company, why the company failed, what happens afterwards, a fixed gear version of the Venture called the Spirit with a smaller engine, and what the future might hold. In the beginning, Jim Griswold and Ed McDonald were amazing engineers. I didn't have a chance to meet Jim, but I had a chance to meet Ed McDonald. A short story about Ed. When he was first got out of school, he was an aeronautical engineer. He went to work for Vought, I believe it was, and he went for an interview. And they were walking around in Vought, and they said, "Oh, we got something cool going on in that backyard here. Let's go take a look." So they go out there, and here was this machine. Had no wings. It had a giant propeller on the top of it, and a little propeller off to the side of it. And this crazy Czech was trying to fly it, named Sikorsky. So he got to see Sikorsky test flying the first helicopter. And that was sort of the beginning of his career. At the end of his career, he was personal friends with the chairman of Honda Aircraft and was consulting at 90 for them on the design of the Honda aircraft. Just a real Renaissance guy. Jim was a very capable engineer. So both these guys worked at Piper Aircraft. Jim was a head of engineering, and Ed was the chief design engineer for Piper. And these two guys came out with the Malibu. Remember Piper kind of built these stodgy old airplanes? And then all of a sudden they came out with this really sleek, pressurized 6-passenger airplane that would go up to 25,000 feet and do 200 plus knots. These were the guys who came up with that brainstorm and developed that airplane and built it. So they both got ready to retire, and they became interested in 1984 in building a two-place high-speed cross-country aircraft. They formed a company called Questair Inc. While they were doing that, two other people joined them. This is Rich Gritter. Rich was the test pilot for the Questair Venture, and also he's an engineer and also contributed to design and construction. Rich actually was the chief test pilot for the Honda Jet as well. And then Jim's son had just graduated from college. He was a aeronautical engineer. And he had a skill nobody else had. And that was, he knew how to do CAD/CAM. And nobody was building airplanes based on computer-aided design at that time. And so this was one of the first amateur-built aircraft kits that was designed completely on CAD/CAM and completely machined with using CAD/CAM. They hooked up with a guy by the name of Don Goldwyn, who owned a company called Atlantic Aero, and he pulled some investors together, and off they went. And in the process, they also hooked up with North Carolina State University and NASA to work on the project. Oops. I'm going to walk you through the development really quick. So they built a prototype. Originally the design was 250 miles an hour, not 250 knots. And it was going to use a slightly smaller engine. And so they built that one. Had the same general characteristics in airframe. They found a lot of problems with it, and they came up with improvements for it. One of the big problems was the landing gear. The airfoils are thin enough that you can't get the gear up into the wing, so they bring it up into the fuselage. And that took quite a mechanism to make that work properly and keep it light and simple. So they were thinking about, okay, we've got to get a second prototype, but we want to put a bigger engine in, and we want it to go 250 knots. And Rich Gritter made that happen because he was on a test flight in the Venture, exploring the high-speed regime, and the canopy came off. And it's got a blown bubble canopy. So he immediately got hit with 200 plus an air blast. It blinded him. It temporarily. It sucked everything, his headset, everything out of the cabin. And all he could see was kind of a blurry blue and a blurry green because he was flying over North Carolina. he managed to get back to the airport, crash it on the runway, didn't get injured, but pretty much totaled the prototype. So they said, oh, I guess we better get it started on the second. The Venture went to Oshkosh in 1987. It showed up. It started flight testing on July 1st, and it showed up at Oshkosh right at the end of July. So they flew its 40 hours off. And it was just a real hit at the show. I mean, they were doing, you know, high-speed passes, like I should show you. I don't know if, yeah, I showed you that one. And I mean, here's this airplane, and you know, they were in a dive, so they were pushing 300 knots, going down the show line, and it's small, so it looks like it's really screaming, and it's got that really cool sound that comes from that engine. And I mean, people, there were lines miles long to sign up to buy a kit. Of course, they didn't have any kits yet. What they had was, they had started gearing up with people to produce the parts for the Venture, to stretch the skins, to, there are a lot of aluminum castings in the Venture because they tried to keep it as light as they possibly could. So they had to line up these companies to cast the parts, machine parts. And so they had done their homework to get things started and ready to go, but they didn't want to commit till they knew how popular it was going to be. So then they went into kit production, and they had about, I'll look at my next slide here. Oh, okay, I'm going to talk about, okay. Let me talk about setting records. Okay, so everybody wanted to grab one of these new airplanes and get it flying. So, you know, there's some real enthusiasts associated with them. And right off the bat, with the prototype, the second prototype, they set the world time to climb to record to 3,000 meters, 6,000 meters, 9,000 meters. They set the closed course records for 3 kilometer, 100 kilometer, 1,000 kilometer. This was in their class. And then they started racing at Reno and other races. And the Venture was winning all these races. At Reno, there were 2 guys that did most of this, Tony Crawford and Mike Dacey. Tony's airplane, he retired just recently, a couple of years ago. It's in the Oshkosh Museum. He has a bunch of records and places in Reno and other races, and they're all listed on the side of his airplane. Was Chicks Delight. It was all on the side of the aircraft. And Mike Dacey pretty much focused on Reno, and he wanted to win the Super Sport class, which is the class just below the Unlimited class, piston aircraft class. And he placed several times, and finally in 2010 he won the race. And his average speed was 374 miles an hour. And he told me, I talked to him afterwards, he told me, he said, you know, in the straights, Will, I was hitting 420 miles an hour. And the other thing he said, well, he said 2 other things. Then he said, but it helps to have 750 horsepower. So he had twin turbochargers on his, it was actually a standard Continental IL 550 engine with, you know, anti-detonation, they squirt that stuff in and prevent it from detonating, twin turbochargers, and he was making over 750 horsepower. But he said, where I really did the best was in the turns. He said, I could catch almost anybody in a turn and get past them because of these high aspect ratio wings, right? These high aspect ratio wings lower the induced drag, and the induced drag is associated with how much lift you're generating, right? So in those turns, you know, these racers are pretty much pulling about 2.5 to 3.5 Gs all the way around the course, except for one flat section in there. So when you go into a turn, there's a lot of drag, right? Any of you that have pulled a 2G turn, a 60-degree bank angle, you notice you have to have power to keep it going. The Venture would lose less speed in those turns because of the high aspect ratio wings. Is this interesting to you guys? Is this okay? I worry about Fabian. He's going, what the heck is he talking about?
Did he do any other modifications besides the 750 horsepower?
He did. So the wing skins on the Venture are 32 thousandths. He went to 40 thousandths wing skins and tail feather skins. That increased the strength of those of those. They did have some accidents venture, and there was one fatality of venture, and I'll tell you about that in a little bit. I think that was pretty much
Did
it.
he lighten it by taking out any of the radios or any other standard?
Oh yeah, I'm sure it was as light as he could make it. Yeah. So the venture company failed after, and they failed for a few reasons. They really never had a good business plan. And there were a couple aspects. One was the original price of the venture was just under $50,000. And that included a brand new Continental engine, brand new Macaulay prop, and a spinner, everything you needed, plus engine instruments and some flight instruments. It was really, it should have been twice that. So they were losing money from the beginning. Yes, sir.
And how long ago?
Hey,
was
Steve, how are you doing?
that? Excellent. How long ago was that?
So this, let's see, we went to Oshkosh in '87, and the company collapsed in '96. So this was, I mean, that was the initial price that they started off at. Later on, it went to about $60,000, but they were still losing money.
So how much would that be in today's dollars?
$1.25?
Well, this was in the '80s, so.
This would be about somewhere between 120, 150-ish.
Okay, there you go. 120, 150,000. But the costs were out of control. The investors really originally put $1 million into this company, which is a fair amount of money back in those days. In 1984 is when they did it. And the company was spending money. This is a real classic aviation story, right? Amateur-built aircraft. They were spending money faster than they were making it. They kept asking for more money from the investors. It went up to $4 million, and then the investor says, "Okay, that's it. That's enough. You know, this is not working." And so they pulled their money in 1996, and then the company went into bankruptcy. But along came Bob McClellan and Henry Boulay, and Bob McClellan was a real estate executive. He was the money guy. And Henry was an engine builder and also built parts for certified aircraft. And they said, "Oh, we're going to be really successful. First of all, we're going to charge $90K for the kit, and we're going to make it fly higher and go faster." And they said, what we're going to do is we're going to put a 350 horsepower twin turbocharged engine so this airplane can go to 25,000 feet and do 300 knots. Now 300 knots is kind of getting in the sort of the jet range, right? So this was going to be a real rocket ship. It was already a rocket ship, but this was going to be something else. And so Henry was an engine builder, and he decided that, okay, I want to build the best engine I can, except he couldn't get a forged crank. So he machined a crankshaft out of a billet of steel. Now this is going to tell you why you don't want to fly airplanes with cast cranks that aren't forged, okay? So he's flying this airplane, they're doing some tests, he and Bob are up there at 16,000 feet scooting along. I think they were probably doing 280 knots, 275 knots, and the crank let go because it wasn't forged. They did a lot of analysis, on metallurgical analysis afterwards to see what happened. And it broke in two places. So they had an engine failure. They were over an airport. You need to hear the radio calls, but they were open an airport. The engine was running rough, and then they thought it was coming back, and then it got even rougher, and then I'm coming down, and so they're spiraling down over this airport. We lost the alternator. It shook the alternator off the brackets. We lost the alternator. The battery's going down. We're going to put the gear down. They put the gear down. Their descent rate went from about 800 feet a minute to about 2,000 feet per minute. The gear is a lot of drag, and it's designed to be that way to slow this thing down, because you got to slow these airplanes down. And they came up short, and they stalled the airplane and spun it at about 1,000 feet ATL and killed them both. So that was the end of Venture 2.0. Went into bankruptcy again, but by this time there were 120 kits out there. People were building ventures, and the owners and kit builders decided that a few of them decided they wanted to go in and buy the assets. One guy was Richard Clausen. He went and purchased a lot of the assets, which were remaining kits in the remaining parts production. Another guy by the name of Alan Toll started Venture 3.0 called New Venture. Alan was a remarkable builder. He built a Venture, which takes about 6,000 hours to build, in 1 year. So I don't know when he ate or slept or anything, but he had built a lot of RVs. He knew what he was doing. He was a heck of a builder, but he was a terrible businessman. Yeah, they all were. I remember, I followed this company a long time. I remember going up and meeting Alan and talking to him. He'd show up at Oshkosh with a folding table, and he hadn't even rented a place. He just found some place to set this folding table up, and he'd have a few brochures that he had, you know, like handwritten and copied. And you go up to him and you say, "Hey Bob, you know, my name's Will Fox, and can you tell me about the venture?" And he says, "Well, I'm only going to talk to you if you're serious, and I just don't want to waste my damn time," and blah, 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 blah. He was the most grumpy, disagreeable guy you could imagine. And nobody could talk to this guy without getting pissed off. So he never sold any ventures, but he had a lot of the remaining kits and parts. And then came a guy, another venturist, Larry Woods. He was a Canadian, really, really good guy. And he was a friend of Jim Griswold's. And there were some warts on the venture I'm going to mention quickly. And Larry said, "I want to fix these warts, and we can build some kits to make this airplane even better. And Jim, will you help me?" So they got together and started working on it, and Larry started making these kits to fix things. And providing those, and also providing some spare parts. Well, things were going great, but Larry caught cancer and he died. And so along came Venture 4.0, Questair 4.0, with Jim Cook and Dan Myers. They were enthusiasts. Jim had built a Venture very early in the game. Had been very successful in an avionics shop he owned in Miami Beach. And they started Questair 4.0, and they rescued all these parts and kits and the manufacturing data for the aircraft, the drawings, the CAD files, everything, and brought it to Mississippi. And they're still functioning right now, and basically they provide Venture and Spirit owners with parts and technical support, but they're not building any kits. They're really, both of them really good guys. Okay, the Venture has a few warts. There were landing gear flaws, fuel tank leaks, trim cartridge wear, and stub spar cracks. The biggest problem with the Venture were low speed, loss of control. Nobody got hurt in these accidents except one person, and he was killed in the accident. But out of 17 accidents, basically everybody walked away without any trouble. And what would happen was there was this really quirky landing gear design, and one of the mistakes, and this was a mistake that the engineering team on Venture made, was they had the incorrect gas-oil ratio in the main gear struts. So you know, in a shock absorber, you got to have a certain amount of gas, a certain amount of oil. The oil gives you the dampening, the gas gives you the spring. Well, they had too much gas and not enough oil. So the main gear struts were just all over the place. They were really springy, right, with hardly any dampening. And that would get you in an accident. If you were landing in a crosswind and the wind shoved you to the side, well, that shock would compress, right? And you'd start to go that way. The pilot would make a correction, and about the same time, the strut would pop back up. And so then there'd be a bigger swerve. So it induced these pilot oscillations. They were worst when you got below 30 knots because your rudder was less effective and you were using nose wheel steering. And they had a screwy nose wheel steering too. And so get this, you know, normally when you steer a nose wheel on an aircraft, from the rudder pedal, there's a mechanical linkage that goes up to a bell crank that steers the nose wheel, right? Well, that was too heavy, too expensive. So what they did is said, we'll take the hydraulics coming off the brake and feed them to a hydraulic actuator that does that. So the idea now is, when you push on a brake, say you push on the right brake, you're pressurizing the caliper of the brake, on the right brake, but you're also shoving the actuator to turn the nose to the right. okay? And so, depending on how much pressure you put on the brake, the more you turn the actuator. And God forbid that you actually hit both brakes at the same time, because then you couldn't change wherever the actuator was. You couldn't steer it, because you couldn't do differential pressure. So then these guys would be in their second PIO going off the runway. Oh, heck, and they'd hit both brakes. They couldn't steer. They couldn't change its direction. And they'd go off the runway, hit a pothole or a ditch, break the nose gear off, sometimes flip over. Larry Woods, that happened to Larry Woods. He said, yeah, I was upside down in the mud, and I was kind of sinking down in the mud, and I was watching it go by the canopy. I was wondering if everybody was going to get me out past the canopy, right? So 5 guys came over and lifted it up so you could get out. But that created a lot of accidents. They weren't fatal, almost no injuries with that one exception. And here's the really bad thing, and this is something to know about amateur-built aircraft. If you're going to buy an amateur-built aircraft, and you have 30,000 hours as an airline pilot, make sure all the controls work the way that everybody's used to them working. Because I'm going to show you in a minute that most of the accidents that occurred to the high-time pilots. And it's the law of primacy. You react in an emergency to how you reacted for thousands of hours, not to a new screwy steering system where you gotta just sort of tap this and get it back straight and then hit the brakes. So, and they had a problem with the nose gear, caster angle, and it was prone to shivvy and need a lot of attention as well. To show you the difference, Jim and Larry got together, built a kit to change that gas-oil ratio. So this is the first year kits were being sold, so there was only one accident. Next year it jumped way up. It sees loss of control at low speed accidents. Stayed there, stayed there. This was the year that the kit came out. And you can see suddenly a dramatic drop in those accidents. And it's been refined since, and basically we don't have those kind of accidents anymore. There were some fuel-related accidents. There were 6 of them. 3 of them were due to pilots who don't know how to change the fuel selector on their airplane, don't recognize when they're running out of fuel, basically pilot error. And 2 of them had to do with a kooky fuel system. The Venture had a big sump tank, so that if you took off with the airplane without the fuel selector in the on position, you had about a gallon of fuel, and that would get you up to pattern altitude. And that was the idea, was you could totally screw up the fuel system, get to pattern altitude. But it was a big tank, and it had to have a flapper valve in it to prevent the fuel from sloshing around and sloshing back out. And this little valve was, you know, just a piece of aluminum on a piano hinge. And if you didn't install it just right, you either wouldn't get a good seal or it could stick, jam. And so some of them jammed, and they caused accidents. And then there was one accident due to a vapor lock, and where the fuel and the lines in the engine got hot enough to generate some vapor. So that was easy to fix. Let's put a system in that's more conventional, like you have in a Mooney or a Bonanza or something like that. And so people started building them that way and didn't have a problem. There was a trim cartridge accident. So this is looking inside. Almost all the controls for the Venture are right behind the dash. And one of the things they did with the Venture was the following. First of all, they put a side stick in. And think about this now. You've got a side stick, and the muscles you use to roll the airplane are your wrist muscles. Okay, not exactly the strongest muscles on your body. When you want to pitch the airplane, you use the stick back and forth. You're using your shoulder muscles, a lot stronger than your wrist muscles. When you want to yaw the airplane, you're using these massive muscles in our legs. And so what you want is you want the muscles that you're using to be similar to the controls, deflections that you're trying to get. One way to do that was to build something called a spring cartridge, where they put springs in, and they basically center, and if you move the valve crank one way or the other, it preloads the spring one way or the other. And so you could put light springs into the roll control, heavier springs in for pitch, and even heavier springs for rudder. And you can make them all feel right, just feel exactly right. So they used to try to do this with aerodynamic balancing, but that's hard to do, to get the surfaces to behave the right way. So this was a really good idea. Cirrus actually adopted this idea, and part of the reason was Jim Griswold was a consultant for Cirrus. And they also adopted the side yoke in the Venture. Okay, so the accident was during a Reno air race. The pilot had put in very soft springs in the pitch direction, because remember you're pulling G's all the way down all the time on this thing, so he wanted it pretty soft. And on top of that, there was evidence he hadn't maintained this cartridge. You've got to make sure it stays lubricated. And there was some wear in it, and it jammed on him. And it jammed at the worst possible time. He flew through somebody's wake, it pitched the aircraft up. He responded. He over-responded. It's not uncommon, right? You over-responded, the aircraft pitched down, the trim cartridge jammed. He didn't know it. And now he's going down, pulled back, wouldn't go, pulled back real hard. Boom! He overstressed the airplane and bent the tail feathers. So bad that they didn't fall off, but the airplane wasn't flying, and he crashed. It was doing about 330 miles an hour when it happened. So later on, Jim Cook came out with a new design that was basically frictionless. You didn't have to worry about the maintenance, and it works great. Is this too much detail? I can go faster. Anybody want me to go faster? Okay. Other Venture accidents. 2 were due to the engine failures. One was the one I talked about with Henry Boulay. There were 2 stall spin accidents. And there's roughly 30 Venture accidents. Only 2 of them were stall spin. So that's way below the normal rate of
How
stall
many
spin.
flying planes? On the 30?
There have been as many as 60 Ventures flying at a time, about half the kits. Right now there's about 30. So this is over a time frame from 2000 to about 2020. There was 1 mid-air collision. Both pilots were killed and their passengers. And there was 1 bounce landing attempt with the go-around, and that caused 1 accident. That's this accident. I'm going to show you a video of it in a minute here. The other thing that developed just about 5 years ago was we started seeing cracks developing in the stub spar in the wing. So cracks in spars, anybody that owns airplanes knows that those happen. This wasn't a huge issue, and I'll tell you why. The Venture has 3 spars in it. It's got a main spar that carries all the lift loads. It's got a rear spar that carries the flap loads and also some of the main loads. And then it's got a little short spar up here called the stub spar. And that helps carry some of the torsional loads in the wing. And what people saw was cracks were forming in the spar, right where the spar went into the fuselage, both top and bottom. And the reason they were forming was 2 reasons. One was the Venture, so it has these 3 spars, right? These 3 spar tabs that have to get inserted into the wing, and then you bolt everything in. Well, when you put a wing on, you got to align 3 things at once, up and down, side to side, by angle, right? On 3 different spars. And guess what? That's really hard to do when you're building an airplane, a home-built airplane. So inevitably, they wouldn't be quite aligned. And this little short stub spar tab was the softest in the system from an engineering standpoint. It was the most flexible, right? So it's the one that always gave when you push the wing in. And so it would always get not always, but if the alignment wasn't right, it would get a little twist in it. And so it would have a preloaded torsion in it. And then you stack on top of that the normal loads that it would see. And so it was seeing more loads than would be normal. And then it was made worse because the plans, this is a channel, this little stub spar up here. This is a finite element analysis picture of it showing the stresses, and high stress areas are in red. It was a channel that came all the way out, but they just wanted a tab. So what they did is they came back in and cut the flanges of the channel off, top and bottom, so they would just have a tab. And when they cut them off at a 90-degree angle, and that created a stress concentration. It should have been radiused. I probably should have had a doubler in it. But anyways, these cracks started developing. They didn't develop usually until after 500 hours. So as a result of that, two things happened. They said, we need to put an inspection hole in so you can see these, because it's hard to get in there and see them with the wing in place. So we can inspect every annual. And we want you to do that after 250 hours for sure. And then inspect it every annual. If you find you've got cracks, pull the wing, drill stop the cracks, and put a doubler in. A doubler is another reinforcing piece of aluminum. And also radius any of these corners if they're not cracked. And so that was the solution to that. Okay, this is a real lesson. You know why your insurance company wants you to have time and type nowadays? If you're going to buy an amateur, they want transition training and some time and type before they'll insure you. Well, I'm going to show you some really strong evidence why that's important. So I looked at all these 30-odd accidents, and I looked at the accident pilots, and I said, okay, what is their average, what's the median of total hours? So this would be the total hours in their logbook over whatever aircraft they flew. The median was 3,000 hours. So these were experienced pilots on average. The highest pilot had almost 33,000 hours. The lowest pilot had 374 hours. Okay? And so your first conclusion is, that seems to affect pilots even with low experience and super high experience. What's going on? Average of 3,000. These are pretty experienced pilots. If you look at their experience in type, that is in a venture, the median accident pilot only had 51 hours, and the range was from 1 hour to 646 hours. And so if you put that on a chart, it looks like this. Pilots that have 0 to 100 hours, almost all of those accidents were pilots with less than 100 hours. As soon as they get into the 200-hour range, it drops way down, and then it just continues to drop as they get more hours. So what this should tell anybody that's going to buy a home built, or any aircraft, really, even GA aircraft, that home belts are particularly important. There's such a range of performance in home belts, and the types of systems they have in them, like this quirky landing gear system, right, that the Venture had. You need to learn all of those, and it takes time to learn all those things in the airplane. And you're at risk until you get trained to respond to that particular aircraft in the system. And that's why time and type is so much more important than total time when you're moving from one airplane to another. Make sense to everybody? Here's the good things though. Great stall spin resistance, monocoque cockpit design, side sticks, and communication between builders. NASA, I told you NASA was interested, so NASA said they were interested in preventing spins, and this is a full-scale venture, full-scale prototype in the full-scale wind tunnel at NASA. And so NASA wanted to experiment with this cool new airplane, and how can we make it more spin resistant? And they said, okay, we'll do a couple of things. First, we'll put drooped leading edges on the outboard portions of the wing, so that they're at a lower angle of attack. So they're not going to stall first, right? It's going to be stall inboard and move out. And that's the way things normally work. So even though you can have a whole section of the wing stalled, the outboard is still flying. And that makes the stall softer, right? It makes it more progressive. And then they said, we're going to put stall fences on it. But this is a really fast airplane, so we won't put stall fences on it. That'd be draggy. We're going to put aerodynamic. Who bit the dust there? I think it was, oh, it's the P-51 and the Bonanza. going to put aerodynamic stall fences on it. So what they did was they put vortex generators right here and about right here. And what they do is these, when you get to high angles, there's no vortex at cruise. When you get to high angles of attack, there's a slot in the wing at a certain angle, and it generates a really strong little vortex that goes spanwise over the wing. And that little vortex acts like a stall fence. So when the inboard section stalls, it's going to go out and then it's going to run into this vortex and it can't jump over it until you increase the angle of attack a little bit more. Then it'll jump over it, but boom, it's going to hit another one out here until you get a little higher angle of the tank. And then it'll jump over that one, but this has got a droop leading edge, so it's not going to stall until you go to even higher angle of the tank. So this makes the wing lose lift very progressively with angle of attack. And that's what gives you those nice stall characteristics. Really cool. I'll tell you something about people that race these kind of airplanes, or people that don't. So the racers said, oh, well, that's going to cost me a knot to have that vortex generator in there, so I'm just going to fill those up, those slots up with putty, with body filler. And the racers also said, I don't need those drip leading edges. I'm never going to stall this airplane, so we'll take those off. And it does. Getting rid of those things gave them a couple more knots. And so what do all the wannabes do? Venture wannabes. Oh, the racers are doing this so they can go faster. I'm going to do this to my airplane for a knot or two. It's like, it's crazy, right? I mean, you're crazy. You're not a racer. You're nowhere near as good a pilot as a racer. Why do this? You've turned this into a much less benign aircraft in stalls. By the way, Cirrus adopted this technology, right? If you look at Cirrus, they have droop leading edges. They have aerodynamic stall fences. Venture craft survivability. So the Venture, it's like sitting in a Formula One racer when you get into a Venture. The sidewalls go up quite high. You're sitting down below, the rear of the fuselage. You're really surrounded by an eggshell, is the way to think of it. And you're what's in the eggshell, right? You're the yolk. And so there's a lot of protection there. And I'm going to show you this accident. Let me get it run. Okay, here it is. Is that moving? There it goes. I don't guess there's any sound with this. Hard landing, rolls, snap rolls the other way. There's a guy in a golf cart right here. So watch it in slow motion. So they're coming in, they got hit by a gust. They were a little slow. It started to stall. You see they recovered, started to roll. They put all the power in, and it torque rolled. I'll tell you a little bit about that when this is over. So here's the guy, right? I mean, he almost got hit by the stuff falling down. That's what it looked like afterwards. Both pilots survived. So if you go back here, let's see if I can put this. I don't know if it's going to show it. I guess I'll go back to one characteristic of the Venture is if I line up on the center line of the runway here and get ready to take off and shove the throttle all the way in, the Venture will go left. And it'll try to lift the right wing, but if it doesn't have any airspeed, it's not. But what it will do is go left, and I can put in full right rudder and it won't stop that. And then I can put full brake in, and it will almost stop it. And what it is for every action, there's an equal and opposite reaction. So when you turn that 280 horsepower loose, the prop going around this way, the airplane tries to go this way. And it's even worse at sea level. So, they always talk about this in the P-51, right? If you jammed all the power in, it would just go off the runway because it's got so much torque. What you need to do is you need to feed the power in gently, and once you get to 30 knots, you can actually just hold it with the rudder. And once you're at about 50 knots, it's not much load at all. So the reason this airplane, you know, when it first hit, you could see it suddenly sink. That was the start of a stall, and it wobbled. The right wings tried to drop. They picked it up. It hit the ground. It bounced. It started to go to the left. And about that time, they were shoving all the power in to go around, and it torque rolled it. And that's why it ended up this way. So at low speed, you got to be careful with all the power. Okay, here's probably the most important thing you can do in an amateur-built aircraft is join the club. Join the club for the amateur-built aircraft. Larry Woods, one of his largest contributions was he started a Yahoo mailing list back where the venture first started coming out. And he got everybody to start talking to each other. And boy, problems get understood and solved in a hurry that way. So, you know, nowadays any type club is going to have a way to join it, and it makes a huge difference. It made a huge difference in the Cirrus accident rates. They had a lot of accidents in Cirrus early on until they got together and said we need to train Cirrus pilots more specifically. I'm going to run through these really quick. So I made some mods to my Venture to improve the ground handling, improve the fuel systems, better ergonomics, manual flaps, stronger engine mount, reduced cooling drag. So we talked about that nose steering problem. One of the problems I had in the Venture was this yoke up here on the nose gear was cast originally. It was cracking due to the loads on the nose gears. So I built a new one. I built it out of titanium, and it's never going to crack. I also put electro-hydraulic steering on the Venture. So in the Venture, right next to the throttle, I can put my thumb on the switch, and if I move it, it's a momentary switch. If I move it to the right, it steers the nose wheel to the right. If I move it to the left, it steers the nose wheel to the left. And it's mainly for low-speed handling. Once you're going 30 knots, the rudder does a great job of steering it. But it also serves as a shimmy damper. So it's attached to this bell crank. This is the actuator, but it's filled with liquid. You know, it's a liquid gas spring, so it also works as a shimmy dampener. It isn't a gas spring. It's just a liquid actuator, and so it acts as a shimmy dancer as well as steering the aircraft. I still use differential brakes to steer too. You can do that too at higher speeds. This is the electro-hydraulic motor and pump, and I put it in a clear plastic housing so I could see if it leaked easy. This is a good one. So again, trying to save weight, they used a rudder bar for the rudder pedals. Normally rudder pedals go fore and aft in plane like this, right? And usually they pivot at the bottom if you've got, they're going fore and aft, but they pivot at the bottom, and then the foot pedal can angle, right? So they go this way. Well, this was on a rudder bar, so they had a vertical bar that came down, and a bar that came out, and the pedals attached to that. So when you pushed right, it rotated. And when you pushed left, it rotated. Okay? And they did that in a lot of, I think even the Spitfire might have had that, one of the early versions, because it's light, it's easy to design, but it's terrible ergonomically because the first thing that happens is, let's say you want to go left real quick, right real quick, you push the right one in, and your foot wants to slide off the pedal, right? Because you, like if in an emergency, right? You push it in, your foot wants to slide off. The second thing is if you've got toe brakes, you dish it in, now you're trying to do this, right? Your foot doesn't want to go at an angle and then work like a toe brake. So it had some problems. So I came up with a 4-bar linkage and made these articulated rudder pedals. So they're still attached to the bar here, but there's a linkage in there so that as the bar rotates, the pedal stays in plane. It's really a pretty simple thing.
Except that the other foot is moving out.
Yeah, and it stays in plane too, so the pedal can stay in plane both ways.
Which is different in a regular plane, where you're only using one foot at a time. And not
Well, the other, even on regular pedals, the other one comes out when you push it. Yeah.
Don't remember.
Well, being a big guy, do you have a tough time fitting yourself into this thing?
I do. But it's worth it.
And getting out?
No, I had to make some modifications for me to fit. Actually, I think I'm gonna get to that real quick. Hang on. The other thing was that originally it just had a seat belt and a shoulder harness. And for me, because I'm tall, the shoulder harness kept sliding off my arm. Plus the shoulder harness is a lousy way to, to use in an airplane, especially if it's aerobatic. So I put in, I lowered the seats so I'd have more headroom. That was the biggest thing. And I'm in a process of putting in a higher panel to give me more room under my legs. And actually, I'm pretty comfortable in there now. But I put in inertia reels, put in a 5-point harness, and I designed it for 26 Gs of forward impact, which is now the standard for designing for aircraft. And that's where you can take that kind of load in a crash and have no permanent damage if you're properly supported. Oh, and I went to Simpson Race Products. They make polyester harnesses. Polyester is stronger than nylon. It stretches left. It has a longer lifetime, less vulnerable to UV, and it costs less. Oh, Venture originally only had one fuel vent. So what happens if that ice is over? You're going to be in trouble. So I added a couple more vents. This is a submerged fuel vent, so it's down, it's up in the wing, so ice doesn't collect on it. The wing tank, it only had one sump, and that was in what would be the equivalent of the gascolator, and it didn't have wing sumps. Well, I'd like to catch it in the wings, right, the water in the wings, so I put a couple wing sumps in there too. There was a problem. There's two huge mounts on the Venture up front, pretty much, well, not really close to the center of gravity of the engine. And then there's a small mount, so it's only got 3 mounts on a small mount in the back. They had a problem with these originally not getting enough compression. They needed a higher strength bolt. They originally threaded into aluminum block down here. That's not a good thing, aluminum threads. So I modified it, put a different bolt in, put an inspection cover so I could get to the nut on the back side. And everybody's doing this now. So you can get the right preload on the engine. It reduces vibration and wear. A couple other things. I put a manual flap system in. The original Venture, when you put the gear down, the flaps came down. It was just a safety thing, right? Put the gear down, flaps come down. Well, you don't want that here in Los Alamos if you've got a strong crosswind, right? So it's easy to modify it so that you can operate them independently. A lot of people use electric actuators for that, like electric flaps. That's really cool. It's electric. It's a flip, a switch you flip. The only problem is in a really fast airplane, when it cruises at 240 knots and the maximum flap speed is 170 knots, it's easy to put the flaps down when you're going too fast, right? An electric actuator is just going to crank them down, right, and overstress them. A manual flap actuator, if you're going too fast and you start to pull that thing, you go, whoa, I better slow down, right, because you can feel the pressure right off the bat. Plus, as long as I'm working, it's working. I don't have to worry about fuses or anything else. And then, this is trying to reduce cooling drag. These are fairings underneath the engine, so when the air comes in, it goes down through the fins, and then it has to exit. And so it comes in, turns once to go down through the fins, has to turn again to exit, right? And usually underneath the engine, you've got all these wires and cables and spark plug and stuff underneath there. If you can make the flow exit without making a sharp turn, and if you can avoid having things that it's going to run into, you can reduce cooling drag. About 10% of the drag of the Venture is cooling drag. So, there's a couple knots right there if you can. I built these seats, getting back to you, your question, Tim. I built these seats right here out of carbon composite, and I built the mount so it would sit lower, and I also made the seats adjustable. They didn't used to be adjustable. And this is my stick shaker, which I wanted to someday hook up to the stall switch. so that the stick will vibrate when I approach a stall. So I tested it and stuff, but I don't have it installed yet. And this is just future ideas for the venture. One last one. This was the Spirit. Now this might have saved the first company, the original Questair. They realized finally that the kit was too expensive, it took too long to build, and it was a lot of performance for just about any pilot. So why don't we build something that's just a little faster than an RV, which was dominating the market. And they said, let's go to fixed spring gear, like an RV has. Instead of a 550, let's put a 360, Continental 360 in there. It's a smoother engine than Lycoming. And we won't need as big a prop, as sturdy a prop. And a big portion of the build is associated with the landing gear and getting it built properly. So they built one, and he basically used the same airframe with those modifications. It would do 200 knots maximum speed at sea level, 180 knot cruise at 75% power, and they called it the RV killer. And it had all the great features that the Venture has in terms of handling and efficiency. It'd be much more efficient than an RV because of those high aspect ratio wings. But they built the prototype, they sold 2 kits, and it was too late, the company folded. So if they'd done that earlier, it might have been successful. So that's all I have. Was that too much? Is that okay?